Hello, good morning, friends. Today we are going to learn important topic, that is differential equation. Differential equation. It's in engineering syllabus. Now, first we'll see that y equal to f of x be a function. Be a function. Now, in this function, we have two variables x and y. X and y. X is called as independent variable and y is called as dependent variable. To differentiate dependent variable with respect to independent variable, we denotes dy by dx. dy by dx. This is called as a derivative of y with respect to x. Here x is independent variable, y is dependent variable. Now, next point is equation. Now, before going to equation, I'll tell you what is meant by expression. Then we'll go for equation. Expression which contains one or two variables and they are related with some mathematical equations. Like that, suppose 2x plus 4y. This is one expression. Or x square plus 3xy plus y square, which containing two variables and their higher second degree and first degree relations between them. These all are called as expressions. Now, expression containing equal signs. Suppose 2x plus 4y equal to 0. Means one variable can be expressed in terms of second variable, second can be expressed in terms of first variable, or any numbers of variable expressed in terms of one variables or two variables, like that. Means here, suppose x square plus 3xy plus y square is equal to 0. These all are called as equations. These are called as equations. Means second equation, both left side and right side must be there in the equations. Then you call it as equation. These are expression and these are equations. Now, suppose in the equation, in the such equations containing derivatives, like that. Suppose here get 2x plus 4 into dy by dx equal to 0. This equation containing derivative, differential coefficient, also you call it as. Now here this derivatives and equation and such types of equations are called as differential equation. These are called as differential equation. Means an equation containing differential coefficients are called as differential equations. Now we'll go to next slide. Now, actually, the differential equation is divided into two parts. Divided into two types of derivatives. One you called it as ordinary differential equation, and second we call it as partial differential equations. Now, what is meant by ordinary differential equation and partial differential equations? I'll explain it within short break. Now here such equations, here number of independent variables is only one independent variable, or one or more dependent variables. Now similarly in postulatives, here two or more independent variables, or one or more dependent variables. Then this is the main difference between ordinary differential equation containing only one independent variable, and in postulative one or more than one also. That means two or more than two also independent variables are allowed in the partial derivatives. And symbolically, here is denoted by dy by dx, or d2z upon dx dy, or dy square. Here dabba y upon dabba x, dabba z upon dabba y, dabba 2z upon dabba x, dabba y, and so on. Okay. So these are the simple definitions. Now, in ordinary differential equations and partial differential equations, these two concepts are totally extended into wide applications form in the mathematics. Now, before going to explain these ordinary differential equations, now I'll tell you what is meant by order. Order of differential equation. Order of the differential equation. Now, number of times differentiated to the variables that is highest order derivatives. Means how many times differentiated it, that number is called as order of differential equations. Now here dy by dx, this is called as first order. d2y upon dx square, this is called as second order. Like that, highest order, how many times differentiated dependent variable with respect to independent variable, that is the number. That number is called as order of differential equation. Now, next, what is meant by degree? Degree of differential equation. Degree of differential equation. Now, here again also maximum index of highest ordered derivative term, that is the degree. Like this, suppose d2y upon dx square plus 3 dy by dx plus 4y equal to 8. Suppose this is a one differential equation. This is differential equation. Why it is called as ordinary differential equation? This is first differential equation. Why? Which containing derivatives. Equation containing derivatives, that's why we call it as differential equation. Second, why it is called as ordinary differential equation? There is y is only dependent variable and x is only one independent variable. X is only one independent variable. That's why here we call it as ordinary differential equation. Now among these all the terms, here one term is differentiated dy by dx. Here two terms differentiated. Highest order means this is a term. This highest ordered power, that is index the power, is called as degree. Now for this equation, degree is 1. Now we'll go for next one. Now suppose if I take one more example, d3y upon dx square dx cube plus d2y dx square plus 4 times dy by dx bracket raised to 3 plus 4y bracket square is equal to 3. Suppose like this differential equation is given to you. This is first, our job is to identify this is differential equation. A differential equation which containing derivative terms. Why it is called as ordinary differential equation? Again here x is only one independent variable. Now which containing derivatives. Next, highest derivative. Here highest derivative is 3 times differentiated. This term is here 3 times differentiated y with respect to x. Then here one more, you can see dy by dx. Here degree is 3. And this term degree is 1. This term degree is 1, and this term degree is 3, and this term degree is 2. Now highest ordered term. Which is highest ordered term? This is highest order. By 3 times derivative. This is highest ordered derivative term. And our job is to check its index, its power of this whole term is 1. Therefore, here for this equation, degree is 1, order is 2, or order is 3, degree is 1. This is how to identify degree and order. Now suppose like this, suppose equation is given to you, root 1 plus dy by dx is equal to d2y upon dx square. Then how to identify degree and order of the differential equation? Now this differential equation containing a root. We don't want fractions or any radicals. These orders and degree must be calculated by radical free or then fraction free indices. Now to remove this root, square both sides. That is 1 plus dy by dx is equal to d2y upon dx square bracket ka square. By squaring both sides, get this is the standard form of differential equation. Now I'll write into model form or proper form. Now here d2y upon dx square bracket cos square minus dy by dx minus 1 equal to 0. For this differential equation, the highest order, how many times differentiated it? That is 2 times d2y upon dx square. This is here highest order d2. 2 times differentiated y with respect to x variable. Let's say order is 2. Now, what is meant by degree? Now, check which highest order term is there. That's degree. This is highest order degree term. Therefore, now here this power, this power of this d2 by dx square is 2. This is 2. Therefore, now degree also 2. Highest order. Got it? I understood what is meant by order and degree. Now we'll go for one more examples. Now, while checking equations degree and order, 1 plus dy by dx bracket square bracket cos square whole raised to 3 by 2 whole raised to 3 by 2 is equal to rho into d2y upon dx square. Like this equation given to you. Like this equation given to you. Then this is not in standard proper way. Why? It contains fractions. It contains a fractions indices. That's why to remove this fraction, to remove these fractions, square both side. Square both side. That is root will get cancels. Means you get 1 plus dy by dx its square whole raised to 3 is equal to rho square d2y upon dx square whole bracket square. By squaring this one, the fraction is converted into proper differential equations or proper order of differential equation. Now, such equations you can calculate what is meant by order of differential equation and what is meant by degree of differential equation. Now, order means highest derivative term. Now, here first order derivative and here second order derivative. This is the second order. Means 2 times differentiated the given function, then order is 2. Order is 2. Now, highest order terms. Here you can see here also 3 is there, and here 2 is there, and but here again inside 2 is there. Means here you can expand it. No, you get divided by dx to 6 also. But this is not highest order. This is first order. Now here second order term is here d2y upon dx square. This is second order term. We check its degree. It's a degree. Now the second order term's degree is 2. Therefore, our degree of whole equation is 2. Second order, second degree. Okay. Don't get confused here. You must simplify and check which term is highest order differentiation. That terms only index you have to check. That is the degree of the differential equations. Now after degree, we'll go for the detailed expression of. Go back all the slides, we erase all the slides you can erase. Now our job is to study deeply solution for ordinary differential equations. Solution for ordinary differential equations. Repeat once again. What is mean by ordinary differential equation? Equation containing differential coefficient, and that coefficient must be differentiated with only one independent variable. Such equations we call it as ordinary differential equation. Now for first year course, we have only first order ordinary differential equations. First order ordinary differential equations. Now, what is meant by first order ordinary differential equations? Now, only one times differentiated differential equation means dy by dx plus p into y equal to q form. Means here this is a differential equation which containing a derivative coefficients, and this derivative differentiated only one times. That is called as first order. This is the here order of this one. Order is one, degree also one. First order, first degree ordinary differential equations. Like that you get, suppose dy by dx equal to f of x, right? Or dy by dx is equal to f of x upon f of y. Like that equations. Means only one time differentiated first order must be there in the equation. Such equations we call it as first order ordinary differential equations. Now, what is meant by solution? Solution of first order ordinary differential equations. Now, dy by dx equal to functions of x and y. Functions of x and y. This is the general formula or method for the ordinary differential equations. Now, these equations are solved by using different methods. Okay. Then we call it as general solutions for the ordinary differential equations. Now, solution for first order first degree ordinary differential equations. That is equation number one type. Equation number one times. What is meant by solution? Solution is a relation between y and x which satisfies equation number one. A solution is a relation between x and y which satisfies equation number one, which contains only one arbitrary constants. Only one arbitrary constants. That is called as solutions of ordinary differential equation of first order. Repeat once again. A relation in y and x, that is dependent variable and independent variable, which containing only one arbitrary constant, satisfies given ordinary differential equation. That is called as solutions of ordinary differential equations. Now, how many types are there to find out ordinary differential equation solution? Now, how many types are there? Types for ordinary differential equations. The first important part is the variable separable form. This is one. Second form, reducible to variable separable form. Third, I'll take only main types. Then homogeneous differential equation. Again, in that fourth is reducible to homogeneous differential equation. Homogeneous equations. Now, fifth is linear differential equations or differential form. Now here also we have that subtype reducible to linear differential equation. Reducible to linear differential equations. Now after that sixth type is that is called as exact differential equation. Exact differential equation. These are the important types. Among these, mostly these are the main four parts, which are the variable separable, homogeneous equation, then linear differential equations, and exact differential equation. These are the main four types, and in that reducible to variable separable, reducible to homogeneous equations, reducible to linear equations, reducible to exact differential equations. Also, there are subtype also for the ordinary differential equation solution. We go for one by one. Then first we'll go for the variable separable form. We'll see one by one how to find out by using variable separable form. Variable separable form. Variable separable form. Now here, which are the main types of the form? There are so many natures are there. Integral, or you can say first you can write equations. Here dy by dx is equal to f of x upon f of y. This is ordinary differential equation. Such equations you can cross multiply or collect the like variables one side. Variable. Now suppose here y is there, the corresponding differentiation is dy, and x is here, x corresponding differentiation is dx. Collect these terms together. That is called as separation. F of y into dy is equal to f of x into dx. This is called as separations of variable. Then we call it as separation of variable. Now once you separated variables, first types of equations, you can integrate both sides. Integrate f of 1 dy is equal to integration f of x dx plus some constant for the integrations. If you take integration on both sides, you have to add the constant term, that is constant. So this is one of the variable separable form. Now sometimes if they ask also second different ways also. Now suppose here like this here dy by dx equal to f of xy form. F of xy form. Here also we can make the separations. Sometimes we get this also f of x into dy is equal to f of y into dx. F of y into dx. Given here x and y are collected, y and x are collected, then separate them in proper way. Then by separation dy by f of y is equal to dx upon f of x. Means separating y terms together, x term together. This equations we call it as variable separable form. Now, how to solve such types of variable separable forms? After the separations of variable, integrate both sides. Integrate both sides like terms. Means here f of x with dx term and f of y with dy term. Okay. After that, it may be equal sign or it may be plus sign or subtraction sign, depending on the separation must be done individually variables. X terms together, y terms together, or any variables more than that also you can make them separately. Now after this you have to integrate both sides. Integrate both sides. And while integrating, you have to add the arbitrary constant c. Arbitrary constant c. Let's see on our two examples. How examples will ask in exam and how to make them separate. Now, one example I'll take here. Example first. Here, sec square x tan y dx plus sec square y tan x into dy equal to 0. Consider this equation given to you. Now, here just you observe it. Here we given dx term and we have here dy terms. Now, with dx only x is required. We don't want y terms. And here y only y is written. We don't want tan y. To separate them, divide both sides by tan y into tan x, or you can cross multiply also. By dividing, we get sec square x upon tan x dx plus sec square y upon tan y dy equal to 0. Now you can see here all the x terms are collected together, here all the y terms are collected together. And this we call it as variable separable form. This is called as variable separable form. Once you got variable separable form, then to find out solution, go for directly for integrate both sides. Integrate both sides. Sec square x upon tan x dx plus integration of sec square y upon tan y dy equal to arbitrary constant c. You can take left side or right side also, arbitrary constant you can add any side, but you can take one arbitrary constant. Now to solve this integrand, we have the formula. The formula is here, I'll writing here. Integral f dash of x upon f of x dx is equal to log of f of x. Log of f of x plus c. This is the formula. Means denominator derivative is there in the numerator. Such terms you can take integrate directly. Then this answer you get log of tan x plus log of tan y is equal to constant. Now I got here constant c, but by integrating you getting log terms. Then you can convert them. Then you can take this also log c. Then it's easy for the simplifications also. Without taking also you get the same answer, but you take easiness for it to taking log of both sides, you get some. Now here log f plus n formula, then log of tan x into tan y. So you get one log term, log m plus n formula, log m into log n formula equal to log c. To remove log, take exponential power on both sides. Exponential power both sides. Then you get tan x into tan y equal to c. This is our solution for given ordinary differential equations, which containing only one arbitrary constants and relation between the x and y variables. X and y variables. So this is called as solution for ordinary differential equations. Got it? Now we go for one more simple examples where you can get the terms. Example number 2. dy by dx plus 3x is equal to 0. So for the simple ordinary differential equations. Now how to make it variable form? dy by dx, keep one side, shift minus 3x this side, we get minus 3x. dy equal to minus 3 into x into dx. Then this relation becomes variable separable form. Variable separable form. This is variable separable. Now once you got variable separable, then integrate both sides. Integration both sides. Integral minus 3x dx plus arbitrary constants. Plus arbitrary constant. Integration of dy is y is equal to minus 3 x square upon 2 addition of x square, x is equal square upon 2 plus arbitrary constants. And this is solution for given ordinary differential equations. Why this is called a solution? Which contains only one arbitrary constant and which contains relation between x and y. This is called as ordinary differential equations solutions. Now like that we can solve so many ordinary differential equations. Now sometimes the given equation is not easily separable form and we need to substitute such terms, it becomes a variable separable form. Now suppose we'll take one example, dy by dx is equal to sin x plus y plus cos x plus y. Now such terms, here x plus y is the compact form, we can't separate x and y. Such cases we need to replace, put x plus y equal to another parameter, say u. So once you replace here, then differentiate it 1 plus dy by dx, 1 plus dy by dx equal to du by dx. Now here y and x variables are converted into x and u variable forms. Okay, change of variable form. It's also called as change of variable form. Now this form becomes dy by dx is equal to du by dx minus 1. Means given equation 1 can be reduced into new variables. Now given are x and y variables. Now it becomes u and x variable. Change of variables here. Y to u. That is called as reducible to variable separable form. Now after this substitution, what changes becomes in the differential equation? Now equation number 1 can be written as, in place of dy by dx, we are going to replace here du upon x minus 1 equal to, get sin u plus cos u. Sin u plus cos u. Now here you can write down du upon dx equal to 1 plus sin u plus cos u, which containing all the u terms, then you get 1 upon 1 plus sin u plus cos u. This is the u terms into du equal to dx, into du equal to dx. Now how to solve such types of equations? Now I'll erase this numerator. I'll take care of it, then it will get easy for us to integrate. Now, to convert this system of equations into solvable form. Now, we have 1 upon this 1 plus cos u. I'll mix together 1 plus cos u, 1 plus cos u. I get 1 plus cos u plus sin u. 1 plus sin u, 1 plus cos u. Here 1 plus cos u is nothing but 2 cos square u by 2, half angle formula. 2 cos square u by 2. And sin 2 is 2 sin u by 2 cos u by 2. Sin 2 by u by 2 cos u by 2. This you get. Now, if you divide both sides by 2 cos square u, dividing both sides by 2 cos square u, you get equation form. Integral by dividing this term to the both side. So here is du is equal to dx. Multiplying, dividing both sides and numerator and denominator. Here get to divide up numerator, get 1 upon 2. 1 upon cos square means x square u by 2. Then divide by, get here 1 plus 2 sin u by 2 cos u by 2. And for these terms we are dividing by 2 cos square u by 2. This is the denominator term. Numerator is 1 upon 2 cos square u by 2 is nothing but 1 upon 2 sec square u by 2. And this is du equal to dx. Erase this part. Got it? Now we'll go for the next question. Now here 1, 2 get cancels, here 2 get cancels, 1 cos get cancels. Sin upon cos means tan you get. Here 1 upon 1 by 2 sec square u by 2 upon 1 plus tan u by 2 du equal to dx. Now here if you differentiate denominator, you get numerator. If you differentiate denominator, you get numerator. Then we have to apply the formula f dash of x upon f of x dx equal to log of again f of x formula plus c. Now if you differentiate this denominator, you get numerator. Therefore, as solution you get log 1 plus tan u by 2 equal to x plus c equal to x plus c. We have to integrate this also. Now here replace u by our substitution method. Log 1 plus tan u is nothing but x plus y upon 2 is equal to x plus c. Okay. Like that you get a solution which containing x and y only, not u and x. U is for our convenient, we are replace it. U is not our variable. U is assumed variable. That's why I replace back into the original variables. Then you get the final solution. Okay. We go for next slide. Now, like that, you can solve any multiple types of examples to reducible into form. Now one more example you can see. dy by dx is equal to root y minus x. Root y minus x. Now here again is not easily variable separable. Then put y minus x equal to another parameter. Take t or t square. Why I am taking t square here? Your root is this one. Okay. Then differentiate it. dy by dx minus 1 is equal to 2t dt by dx. dt by dx. Therefore, dy by dx is equal to 1 plus 2t dt upon dx. Then question becomes 1 plus 2t dt upon dx. 2t dt upon dx is equal to t square root, means t. This whole bracket is t square and root is there, is t equal to t. Now you can separate these variables. How to separate it? 2 into t dt upon dx equal to t minus 1. t minus 1. Now you can separate here. 2t upon t minus 1 dt equal to dx. And this is variable separable form. This is variable separable form. And this you can solve by integrate. Variable separable form. So integrate 2t upon t minus 1 into dt equal to integral dx plus constant of integration plus constant of integration. Now how to integrate such special questions? Now this side 2 you can take right side, dividing this 2, integral becomes t upon t minus 1 dt is equal to integral dx upon 2 plus c by 2, same as again c by 2 same as c. Then we go for such types of condition. Now while integrating, where is it? While integrating this integrand, the right side, left side, t minus 1 t plus, let's add 1 subtract 1, and t minus 1 dt equal to x by 2 plus c, x by 2 plus c. Now separate, we get t minus 1 upon t minus 1 dt plus integral 1 upon t minus 1 dt equal to x by 2 plus c. Therefore, this get cancels, means 1 remaining, 1 t answer t plus this is 1 upon it there, log of t minus 1 is equal to x by 2 plus c. Now this is not a final answer. Replace t value y minus x plus log of y minus x minus 1 is equal to x by 2 plus c. This is your final answer, which containing x and y variable with one arbitrary constant. This is called as solution for ordinary differential equations in variable separable form. Okay, stop here. In the next lectures we'll learn how to find out solutions for the homogeneous system of linear equations.